Okay, so this question deals with distances very close to Earth. So we look at the uniform field. We already know that gravitational potential energy goes like mgh. Now this is about potential, which I suppose we could say is V. And that's the gravitational potential energy per unit mass. So in fact, potential goes like GH. And you can see here that for every 1 meter, if that's a change in 1 meter, then the change in the potential is going to be 9.81 joules per kilogram. So we set 270 meters to minus 400 joules per kilogram, and 271 meters would be closer to 0. Hang on, let me think about it. Is there more or less potential? Yeah, it's going to become more negative, isn't it? This is going to be minus 409.81. And if we go up 1 meter, it's going to be minus 390.19. Now, it is an approximation, so this idea of it being 0, we can just ignore. It's an arbitrary value that they've chosen. So don't worry about it being 0 at a certain point. At 110 meters, I'm going to find that gap there, which is 160 meters. I'm then going to multiply it by 9.81. And then I'm going to add it to the 400. So that should be minus 1,969.6 joules per kilogram. And at 370 meters, that's 100 meters up, I'm going to do 9.81 times 100. And I'm going to do 400 minus that. So in fact, I get 170 meters. And let's get that box out of the way. So that's going to be 541 joules per kilogram, because I've done minus 400 plus 981. And so an 8 kilogram mass has dropped from 370. Sorry, that should be 370 to 110. The change in height is going to be 260 meters. What is the work done by the field? Well, in this case, it's simply mgh, isn't it? It's going to be 8 times 9.81 times 260. And the field is going to do work on the mass, so I'm expecting that this is going to be a positive number. And I get 20404 joules